Here we have the 11:15 presentation by SensePost, A Tale of Two Proxies.
Hi. I'm just gonna clip this thing on here. See how that works out. Okay, are we all set? All good? We're gonna close the doors there hopefully sometime soon. Welcome to everyone to this talk, Tale of Two Proxies. This is the 5th year that we are presenting here at BlackHat in Las Vegas. So it's a kind of a monumental day for us. We also had a staff member that was working for 5 years for the company, Gareth. Thanks. Okay, so Tale of Two Proxies. Just to give you an idea where we come from, we're the same guys that did Wecto, Crowbar, BD Blah, the producers of Hacking by Numbers, Satiri, Putting the T in Cyber Terrorism, the directors of When the Table Turned, several Singer's fairy tales, and of course, the inspiration of the Matrix trilogy. Not really. So, what does this talk about? We're going to talk about two proxies. They're very different. I'm presenting the Suru proxy, which is a web application proxy, and my beautiful assistant over here, which you can't see, well, there's nothing happening here. Okay, this. He's going to be presenting on a thing called LR, which I think stands for Last Resort Proxy, which is a generic TCP proxy. Now, these things must not be confused. There's two different presentations. It's basically molded into one presentation, and they serve very different purposes. So why do we need yet another proxy? So this is the Suru proxy, the web application proxy. Why do we need yet another proxy? We have a couple of proxies out there, right? We've got the at-stake web proxy, web scarab, Paros, all of those. So why did we build another proxy? Well, at SensePost, we do a lot of web application testing, and we really wanted something that can start off by doing a little bit better file and directory finding. Now, you know, in Wecto, we have this back-end, system that finds files and directories, but it actually didn't work that much. It didn't work that well. So it was just not cutting it anymore. And we wanted something that can do proper fuzzing of parameters within a web application, and do it really intelligently, but don't do it too intelligently, because if you try to do it too intelligently, you give away a lot of the flexibility, and we'll see later what that means. So I was looking around at, you can see this orange sea of people sitting over here. I was looking at how these SensePost people are doing the testing that they do on web applications, and I found a couple of things. The first thing is there's no one-button web application assessment tool. So you can't press this button and all of a sudden you find all of the problems. And I don't think we will ever have something like that. There's a lot of people that attempted to do that, and in my opinion, I don't think they really got it right. What we've also seen is that people that are really good at web application assessments want to be in control of every request and response that they're getting back from the server. They want to be they want to know exactly what it is that they are doing. And while they want to be in control, they also want to have, they're also performing some actions over and over again, but they're not performing it over and over again to the extent that we can automate it. This is kind of doing the same kind of thing. So what we wanted is to automate some parts of the process, but not have automation of the entire process. The other thing that we also found was that a lot of the lines between the web application and the web server were kind of blurring. And it was difficult to determine where the web application ends and where the web server starts, and the operating system. So we decided to build a proxy after all and see how we're going to do this. And it really didn't happen in one day. So I'm going to give you a brief history of where we get to this. We wanted something that would work like Nicto, but won't be fooled by friendly 404s. And so we created Vector in 2004. And there's a little bit of a pity because a lot of the people still don't know how that AI little, radio as a checkbox, how it actually works. And really the cleverness of Vector sits within the content comparison algorithm that we have. We created a tool called Crowbar early in 2005, and most people don't know how to use it, let alone know how it works, which is also a pity. Because here we expanded the thinking a little bit, and we said, we want to create a thing that can generically, because this is when I say something wrong when you do that. Okay. We wanted to create something that we can send generic TCP requests, not generic TCP, generic HTTP requests, and basically look at the response and see how the response differs from request to request. And at that stage, we found that Crowbar was really very powerful. It was one of the most powerful tools that we created up to that time. And we actually wanted to take that a little bit further into something that's a little bit more usable. We also wanted a proxy, normal kind of web proxy for EOR actually. And we took some code and we started butchering that a little bit, and we ended up with a thing that we called Suru, which we got kind of started on in early 2006. So if we say that people don't know how the AI options and the stuff works in Vector, let's explain it. And hopefully this will be the last time. The content comparison algorithm is basically compares two strings. Okay? So in Vector, it compares a response for a test case and for the real case. So if we look for something called, let's say we want to determine if login.pl exists somewhere, we would first do a base response request, that's that BRR, base response request, for something that doesn't exist, like moo.pl. And then we do the real test for login.pl, and we compare these two responses and see if the responses match. If the responses match, then of course the file doesn't exist, right? Because unless moo.pl actually does exist. In Crowbar, we do the same thing. We define there what we call a base response, and the user can choose what the base response should look like. And then for, let's say, a login page where we want to test a username and a password, we'd first test for a user called moo, password called blah, get that as the base, and then look for a real test, let's say, with admin and a password of AAA, and see if those responses match. Again, if the response match, then we know that that login attempt was unsuccessful. If it doesn't match, then we know, something else happened. So for the first time, since we're beginning with this, I'm going to show you how that content comparison really works, because it's really simple. It's not that hectic. So the first thing we do is we crop the header, if possible. If there's nothing in the body, then we take the header. But if there's something in the body of the HTTP reply, we crop that header, and we split the two strings that we want to compare on new lines, on close brackets, and on spaces. And that becomes two collections, like collection A and collection B. We count the blanks in both items, and then we have a little thing that basically just runs through the loop of collection A and collection B. It says if item A equals item B, then increment and counter. And if you found that word, break, so don't look for it again. And at the end of the day, return the counter times 2 divided by the sum of the items in both of the collections minus the blanks. So it looks a little bit like, looks a little bit like this. So if we have in action, we can see this in action. If I'm testing two strings, the first is I'm testing this, and the next word is doodle sakduk, and the next string is I'm testing this, and the next word is kaas krulletjies, then it becomes as follows. Collection A is, after it's been stripped of all those tags, the collection in A is I'm testing this doodle sakduk, collection B is I'm testing this kaas krulletjies. So the match count is I am testing in this, which is 4, right? blank count is 0. The number of items in A and B is 5 plus 5 is 10. So we return 2 times 4 divided by 10 is 0.8 or an 80% match. Okay. If, however, we have two strings that almost don't match, I was testing, and the other string, I am testing them things, then you will see that there's only 2 words that match, that is I and testing. 2 times 2 is 4, divided by 8 words in total gives me a 50% match. So this it's as easy as that, right? And it proved to be very effective. What we've also done is we've given then the user the ability to determine, to basically provide a fuzzy logic trigger to see how close they want to be to this. Look, if the two strings are exactly identical, it's going to be 1, right? The return is going to be 1. If they're completely different, the return is going to be 0. So this fuzzy logic trigger basically allows the person then to set the level to trigger when something is quite very different or similarly different. Okay, and you'll see how it works. I know it doesn't make sense now, but it's cool. You'll see how it works. It also, in Crowbar, we did a little bit of content extraction. So we allowed people to say, well, I want to, out of the response that comes back, I want to extract something. In this case, we say our start token is of about, and our end token is /B. Now, you know, if you Google for something, you say so many of about, so many hits, right? So we're extracting that part, and we're just running this with names. So you can see that the name Abby has 45,500,000 hits coming back. The name Abigail, though, has 21,900,000 coming back. So we can extract any kind of part of that response and put it in a file. Basically run through all of those names and actually extract the amount of data that's coming back from Google, anything that we want to extract from that page. That makes it nice for us doing certain things. Okay, now, so why does Wecto suck? Wecto actually sucks for the following reasons. It doesn't suck. Okay, it sucks a little bit, slightly. One of the features that the guys use when they're playing with Wecto is they use that back-end miner. They use it a lot, right, to discover files and directories. But what happens if the entire site sits behind a specific directory, like, say, big site or customer name, right? Then it's never going to find the directories that sit deeper within that. So the answer to that was, within Wecto, we say, well, you have to mirror the site with the mirroring option, extract the directories, right, and put those directories in the backend miner so that those directories will be found, so that recursively we'll find other directories within those directories as well. And that's fine. But what if the site has a form-based login? So let's say, login password. Now, Wecto will never go deeper within that site because it doesn't know what that structure looks like. And that's why it sucks, all right? And what about doing other things? Like you request a file, okay, some strange form somewhere. Why can't we just look for all of the other extensions that we can have there as well? So you search for something called big site scripts, login.asp. Why don't we someone look for login.zip and login.back and login.all of those other things as well? Well, in Wecto we can't do this because we don't know that that file exists. But if we have a proxy, then we actually could know this, right? And we could look for those things. And this is why Wecto sucks. And it's a blind chicken pecking away at the dirt. Right. There's more reasons why Wecto sucks. Okay. If we have something like / let's say big site, we can automatically start looking for files within those directories that we get, right? With Wecto, you can't do that. Wecto doesn't know about those things. If we have a directory that we find somewhere within our structure that is called, let's say, ABC intranet, then why don't we look for ABC intranet on other directories as well? Because it might just exist there as well. It doesn't do any of that stuff. It doesn't have that intelligence. It's not sitting in that loop, okay? And while we're looking at these directories and files, we can look for indexability of those directories as well. So So that was the recon part of Suru, and you'll see if you look at the tool that there's a whole lot of different smart scanning and smart finding out where directories are, where files are, and it makes a lot more sense doing it inline with a proxy. And the other thing that you can do with Suru is also fuzzing. So as soon as we have a content comparison algorithm, we can say, let's send this stuff to our application, right, and see what comes back. And then let's say send something else and see what comes back, and we compare these two results. So let's say you have a form says username equals this, password equals that. We can basically go and we can say, in the part that says username, let's send a couple of fuzzing strings like SQL injection string, cross-site scripting, directory traversal, any of those things. We basically look at how the application behaves, and when it comes back, we match that response to a base response. And at the end of the day, what we can do is we can say all of these responses that we've now had, we can group them together to say those 900 responses, they all look the same. Those 90 responses over there, they all look the same. And these 9 responses yielded this kind of reply. Okay? Which makes it really easy for us to see how the application behaves under different circumstances. So in other words, if I send 1,000 different requests to the application, 1,000 different strings in there, modifying a single parameter, I can maybe get back just 2 different responses. Now doing it manually is just, it's a pain in the butt. So here you can see 2 screens. What we can do with our parameters once we get it in, we can nicely break it down into, get parameters, post parameters, cookies, the rest of the headers, all of those things. And we can give the user the ability to drop down on a drop-down list on any of these and say, this particular parameter, I want to fuzz and I want to see what's going to happen with it. So you see on the left-hand screen, you see action is left. On the right-hand side, I have the ability to fuzz those with different things, and we'll get into that. Okay, so let's do a quick demo of that. I'm just going to do one quick demo of that. Let's say we have a site like this. Okay, just going to clear this cache over there. Yeah, now is the time to give us network connectivity. Log into intranet, log in with, let's say, moo and moo. Okay, login failed. We get that request coming through there. We can see it's a post. It returned with a 200. We can double click on that, get that window over there. We've got username moo, password moo. I can select, let's say, all of the fuzz strings that I want to run. And click on browse. And on this side over here, you see that stuff starting to be tested. Nicely multi-threaded. Those files that we have over here, we can edit, of course, at any stage. Those are just text files. You can put in any of the text files, any kind of text files you want to have in there. Basic password list, common tables, any of those kind of things. Let's just see. Oh, I loaded union select there. Okay, let's just check. It's just a big file that it's loading up. Okay. So on this side, you'll see these are all the responses that we got back. And I can say group these together, auto group it. And we can see that it basically yielded 3 responses. First response says login failed. Most of the stuff came back with a login failed. The second response came back with a nice juicy MySQL error. And the other one yielded us to be logged in. So there's 3 different responses that we could get. Those strings are just a whole lot of different fuzz strings that we put in there. That obviously comes with the proxy. So, getting back to this. I don't want to spend too much time. I don't want to steal time from Arun. You can fuzz anything in the HTTP header. You can anything in the HTTP request, any place, anywhere. You can see here we've actually fuzzing the user agent there because we just insert that fuzz point in there, and we can group results automatically. There's a couple of other things. I don't want to go into that. Can I go into that? You got the time? Okay. We have a thing called automatic relationship discovery that basically compares the MD5, the SHA-1's base64 encoded and base64 decoded part of any parameter with the parameter himself across all of the different parameters that you've ever had. So why do we do this? Well, for instance, if when you log into your application, you get a cookie, and that cookie is sent to you. And that cookie contains, let's say, the MD5 of your username. That's something you want to know, because then things are like really not good at the application side, right? Or if you have a password that ever gets passed along by 64 encoded, the application will tell you this. You can also do search and replace on both incoming and outgoing streams, with the ability to change binary data. As you can see here at the back, we changed the binary character 03 to 30, and it obviously affects your pictures quite badly, because those are binary streams. So you can see the picture, Google South Africa there, coming out really bad. I'm not going to go through all of the reasons why Suru is nice, but in conclusion of this part, Suru is a nice new man-in-the-middle proxy. It really works well. It allows the analyst still the freedom of thought, doesn't try to do things for the analyst, but it gives the analyst kind of power tools to be able to create some of the things that they want to repeat over and over again. It is basically a combination of a useful proxy plus the best features of Webto, Crowbar, and EOR. And one word of advice: if you do work with Suru, it is better to start off with a bit of a more kind of non-complex proxy, because it is an intense kind of tool. But if you do this every day, we use it every day, then Suru might be just the thing for you. We do hundreds of web application assessments, and we kind of know the stuff that bites us, so we basically wrote the thing to make our life easier. The URL you can find there at the bottom. And at this stage, I want to hand over to my esteemed colleague, Harun, that's going to talk about LR, which is the proxy of last resort. Not quite the same. That's a generic TCP proxy. This is more of a web application proxy.
Okay, in the absence of any esteemed colleague, I'm going to have to speak instead. And if I can get the projector going, that would be nice. Lit. Dun, dun, dun. Okay, really quickly. Horrible luck with mic. Okay, quickly for something completely different. Like Roelof said, Roelof's been speaking about the web proxy. What we want to go into now is just a generic TCP proxy. It'll allow you some of the same functionality, but its purpose is pretty much completely different. Okay, quickly the differences. Suru is a well-packaged tool. You see it's got the macOS-style buttons, addresses some unique needs. Okay, LR, we didn't even give it a name. It's pretty much a collection of other people's clever tools and some duct tape. Okay, a disclaimer, almost everything that you can do with LR, you can do in pieces with several other tools. Okay, LR just tries to make it simpler for you. Switches off. Okay, so LR just tries to make it all easier for you, and the point is, gives you the chance to play with some of it. Okay, what does all this mean? For one, it means clearly I have no future in sales or marketing. Okay, so quickly, what LR actually is. Okay, someday it'll be a completely Suruable application for generic TCP connections. Today, it's just a bunch of scripts that let you get into a TCP stream to mess with stuff before you pass it on. Okay? There's pretty much the work done by us is almost nothing. There's two open source projects that deserve all the credit for it. One is Scapy from secdev.org, okay, and the other one is Neil's IPQ module. Okay, so we'll go into both of it. LR is a bunch of scripts written in Python, pretty much just because all the cool kids these days are playing with Python and we didn't want to feel left out. Okay, I'm not doing anything, I promise. Okay, pretty much why we do it is to get you freed from current tools. Okay, so there's a whole bunch of tools that you can use at the moment that force you to work a certain way. And we wanted you to have the ability to say, no, let's try it this way, let's mangle this. We want to shoot ourselves in the foot whenever we can. Okay, so the whole point of it is, in a way, just to get you thinking, to show you the possibilities for some of the fiddling that you can do with the stuff. And in some cases, just to show you how easy it'll be to do this kind of mangling. Okay, I had to pontificate some possibilities, but apparently my English was bad. Okay, so quickly, one of the questions you get straight off is people saying, you can use ngrep, you can use ITR, why are you doing this? And there's two reasons, well there's three reasons if I'm honest with myself. One was I just wanted to play with the stuff. The second reason was all those tools sometimes bump you into certain limitations. Okay, and the last one is all of those tools you've got to replace as your target server. So you, instead of aiming at your server, you aim at ITR and then let ITR relay your stuff through. And one of the things that we were looking for was the ability to mangle packets when you were doing malware analysis. Okay, so you had a box that was compromised with something, it's going out, you want to be able to say, okay, fetch this file. Okay, you're going out, don't fetch this file, fetch something else. So your malware thinks it's doing one thing and you have control over what you let your malware get. Okay, so ultimately our goal was to modify packets, payloads, and headers. We wanted to be able to do this within complex TCP streams, but as simply as possible for us. We wanted to do it in a nice scripting environment, okay, so it had to be Perl or Python because none of us started with Ruby yet. And we wanted to do it quickly so that we could retain our status as Minesweeper champion at SensePost. Okay, so currently you throw on a gateway, either IPQ or IP divert, and all we're doing there is hoping that the packets, or planning to catch the packets as they move through the kernel and move them to a user space process. Okay, once they get to user space, we have Scapy pick up the packet so that we can mangle it, and then we push it out through the kernel again. Okay, that is a complimentary Visio diagram drawn for no good reason. Okay, really quickly, I'm gonna give homage to Scapy. This year, Scapy ended up number 28 on Fyodor's top 100 tools, which means that most people haven't yet figured out how cool it is. Okay, there's a whole bunch of coolness hidden in Scapy yet. There's a bunch of guys putting out tools written with Scapy. If you haven't played with it yet, you really should. These two quick examples are stolen from the Scapy presentation, which was done by Philippe. And basically what he was going for is, he said, building packets shouldn't be any of this malloc, this, free, that stuff. You should be able to do it like you're ordering a burger. I want 2 buns, 2 patties, some tomato, hold the ketchup. So building your packet is simply saying, I want IP this, dest that, flags this, and send the stuff on, and it figures it out. So if any of you remember way back when you were using whole applications to send LAN attacks against Windows boxes, it's now a Python one-liner. Okay, so really quickly, like I said, LR grabs the packet through IPQ, decodes the packet using Scapy, allows you to fiddle with it, and then sends it through. At this point, we were supposed to do our demo of the first demo, which was simply doing a Google request for one thing and having the proxy transform it. Unfortunately, our wireless is shot, so we're restricted to only demos that we can do locally. But that one actually works, and that one should work pretty trivially, right? You're not changing the packet payload size, you're substituting foo for bar, and everything goes through happily. The problem starts to come in when you start changing your payload size. Okay, why is payload size changes interesting? Well, obviously you can recalculate your checksum, but one of the problems is TCP sequence numbers. Okay, really quickly, if you do a Google, it's actually shocking how many people explain sequence numbers just incorrectly on the internet. Okay, and a whole bunch of people do it incorrectly in some books. And that's because if you take the typical explanation of TCP sequence numbers, you have guys saying, well, your SYN packet goes through, you pick an initial sequence number, that host adds 1 and in order to ACK it and sends the stuff back. Okay, now this is clearly wrong. the remote hosts takes into account the size of the payload of the traffic that you've sent through and adds that to the sequence number ACK. Now this causes a problem for us when we're mangling the payload size, right? Because effectively what we're doing is causing a desync between the client and the server. So actually what SPLR needs to do, okay, and that totally gratuitous picture of Charles was thrown in because Charles worked on this Visio diagram last night. Okay, that's Charles. Okay, so what SPLR has to do once we modify content length is watch that the sequence number, which was initially X, okay, so what's happening in this picture, the client sent through a request for foo, it gets to our proxy, which then transforms it to a GET request for foo, foo, foo. Okay, at this point, the problem that's going to happen is the remote server is going to ACK us, but he's already 6 bytes ahead of what the client expects. Okay, so once we get to this stage, we are forced to handle all of the sequence numbers for both the ends. Basically, all we do is fake out both sides. As the packet comes into us, we either add or subtract to the sequence numbers so that both the client and the server still happily think that they're talking to each other with good sequence numbers. Okay, at this point we were supposed to show you the second demo, which was substituting foo for SensePost does Las Vegas, and that also should work if we were able to get to Google. Okay, so we're going to have to skip it and go to local demos at this point. The point is, if we inline, we're now in a position to do lots of other interesting mangling. Okay, it becomes interesting for client-side fuzzing. Okay, send data with a perfectly valid client. As data comes back from the server, grab the packet and inject a whole bunch of junk into it. Okay, the client's not expecting it and it goes horribly, horribly wrong. Okay, it's interesting for any sort of lame client-side security, and if you talk about lame client-side security this year, the first thing that has to come up is VNC's authentication bypass. Okay, so we'll take a look at it really quickly. So VNC had this problem where client connects to the server, they both agree on what protocol they're talking. The server says, hey, you can talk to me with authentication type 2, 3, and 4, and the client's supposed to pick one of those authentication types. Okay, the problem that VNC made, or the mistake that they made, is they didn't check that the client was choosing an authentication type that they offered up. So the server would say, I'd like authentication type 2, 3, and 4, and the client says, okay, give me 1. Which happens to be no security, and the server happily accepts it. Okay, so if we take a really quick look at this, what we've got here is just an ordinary Linux box, okay, and we should be able to xVNC, if I could spell it correctly. Okay, we should be able to xVNC4, if I could spell it correctly, okay, to the Win2K box. Okay, and at this point it gives us a password prompt. If we gave it a password prompt, it would say, that's cool, now you can go through. Okay, and instead what we're going to do is start redirecting our traffic through our proxy. And this time we're going to run our Python script that says, hey, as this traffic comes through to you, substitute the acceptable authentication type with authentication type none. Okay, so that's listening, and this time if we xVNC, you should see that it happily goes through without any authentication. Okay, so the only thing that the proxy has done is stripped out authentication on the way through, and both client and server are happy. And for the duration of this, you should get funny sounds, but your traffic should work perfectly okay. It drives you a little nuts, but other than that, it's all good. Okay, so really quickly, because I suspect I'm rapidly running out of time. Okay, we're going to go to another example. Okay, so if we're doing that, the last example is that obviously we're in a perfect place to alter headers. Okay, so any of your TCP or IP headers. And so we're looking for a good example of this, and we ended up looking at the old FreeBSD ECE bug. Okay, basically FreeBSD bumped into this problem. If I can just ask my beautiful assistant to hold my mic so that it doesn't drown your ears and it makes him look busy. Okay, so FreeBSD had this problem where you pretty much If they had any firewall rule set dropped, installed that made use of an any established except, if your packets had the ECE flag and the ECW flag tagged on, packets would sail through the firewall. Okay, just out of interest, SensePost released an exploit for this in 2001. It took 270 lines of C to make it happen. Okay, using SPLR, it takes 20 lines of Python, 4 of them are comments. Okay, so really quickly, what we're going to look at here is with your regular firewall. Okay, I tried a telnet to the FreeBSD box on port 22, and it gives me no joy. Just to show you guys, I'm not sure if the text will come through, but here's the FreeBSD box, currently unhappy. Okay, and if you check out its firewall rule set, okay, let's just make that clear. Okay, there's an allow TCP from any to any established, and there's a deny all. Okay, so this should be allowing no traffic through unless you are doing ACK tunneling or something like that. Okay, so you see we get no joy on 22. We could try web browsing to it, but quite predictably it should give us no joy there either. Okay, and so again, all we do is go to LR, and this time we tell it, hey, tag the ECE packet onto everything that goes through. Okay, and this time a telnet should come back and give us our header, and surfing to the box should give us joy as well. Okay, so at this point, all we've done, or the demos that we've seen, have just been mangling the payload with size alteration, and now mangling the header. Okay, and the joy of it, like I said, is that it's really simple Python script, so you can fiddle with it as you want. I'll jump back to the presentation and take the mic from Rulof. Thank you, Rulof. Okay, other uses for it, things that make it cool. Like I said, Scapy makes it perfectly cool dissecting the packet. So literally I get a packet in and I say, here's a packet, what's its UDP payload? And it says, well, this is the UDP payload. And I say, well, let's change that resolver from foo to bar and send the packet on. The joy of hooking on to a really clever project like Scapy is that as more people add more packet intelligence to Scapy, it's less work for you. So actually changing a DNS return packet isn't just substituting the string. You need to alter RR records, you need to alter checksum records. I don't understand any of that stuff or need to. I just tell Scapy, build me a good UDP packet and please send this through. Okay, the one thing that it is missing is pretty much what you'd find if you were doing normal debugging in terms of an int3. Okay, so typically a client sends its packet, you start fiddling with it, you send it to the server, but by that time the client's timed out, okay? The client sent its request and it was waiting and you took too long editing it. Okay, so one of the things that we want to do with LR that we haven't gotten around to yet is to possibly start playing with TCP window zeros. Okay, we're putting it out here just because someone here might start fiddling with it quicker. But the thinking behind it is simple. What we figure is, as the client sends its message and we intercept it, we spoof a message to both the client and the server with a TCP window, or TCP window 0. Okay, pretty much telling both the client and the server, we're too busy now, don't talk to us. Okay, both the client and the server go into a hold state, you mangle your packet, and once you're done, you send both of them a window update and allow traffic to go through again. Okay, it's untested, so you could laugh at me horribly once you go back home and try it, but that's how it goes. Okay, so at this point, you should have a trivial, easy-to-use alternative to packet mangling. The tool should put you in a position to mangle payloads and headers. More importantly, you should see that it's a whole lot easier to fiddle with stuff at that level than some of the black magic voodoo stuff that's been going on till now. We'll put LR, which is a whole bunch of the ugly scripts with samples, up on sensepost.com. So you guys can go there and download it. Should be cool. Back to the good-looking one.
Then, as a conclusion to the talk, the following: if hacking is an art, then your tools are really your brushes, right? But a monkey with a brush is still a monkey. So in our courses, we teach We say it's not about the tools, it's about the thinking. It's about the thinking, it's about the methodology. It's not about the tools, it's not about the tools. But, you know, it's nice to have nice tools at the end of the day as well. There's a difference between a paint roller and a fine-tipped paintbrush. We hope to be creating some of the ones here and some of the ones there as a rollers and as fine-tipped paintbrushes. But again, having a paintbrush doesn't make you an artist either. So tools available there, should be available there on www.sensepost.com/research. Any parting words? Mail us questions, comments, all goes to research@sensepost.com, and we thank you very much. Sorry, if there's any questions from the audience now? We always do this, so then, you know, we don't have to.
Yeah. So the question is, does LR have regex functionality? And pretty much, because of how it's built, you get to say, take the payload to string, payload regex, foo bar, and you're good to go. So absolutely.